Hello everyone. In the series of learning data structures, our today's topic is dynamic memory allocation. So what exactly is dynamic memory allocation and why it is important? As we live on this planet Earth, we all require some address so that people can visit us, people can call us, or people can refer us, right? Similarly, for our coding system, memory, let's assume memory is a planet, and each variable is nothing but a placeholder that can holds some values. So each and every variable also requires a address or a place so that we can refer the variable, we can call the variable, and we can do the manipulation on the variable. So dynamic memory allocation is a way of allocating the memory. Memory allocation is very important in programming because uh, when we store the value, when we want to assign the value, we can we have to use memory allocation. Now this memory allocation can be done either before or at the time of program execution. If it is happening before, that means it is happening at compile time. And when allocation happens at compile time, it is known as static memory allocation. And when we allocate the memory at runtime, it is known as dynamic memory allocation. And this eventually allocates memory for the variable declared by the programmer. So for example, let us suppose I'm declaring a character array. If your C concepts are clear, let us suppose I'm declaring a character array, something like this. So here I'm writing the data type, which is char. I'm writing the variable name as A, and I'm giving the size as 10. As soon as I will do this, what will happen? It will allocate 10 bytes because character takes 1 byte. So 10 bytes are allocated in the memory from 0 to 9. Now let us suppose I want to store some name on this A. For example, the name is just 3 letters long. For example, Ram, or the name is Joe. So what happens? Joe will take only 2 bytes. Ram will take only 3 bytes. Then the remaining bytes all are simply wasted. Now assume, let us suppose I want to store a very big name, something which is not coming in or in just in 10 letters, it is coming more than, it requires more character. Then what happened? We don't have a place to store now the remaining characters. So these are few problem when we have to do memory allocation, when we do memory allocation compile time, because before the program, only before the program executes, before what user is going to enter, before knowing that only we are allocating the memory. And in such cases we have to face this problem of not knowing how much size actually my programmer require. So to avoid this problem, we have the concept of dynamic memory allocation. Dynamic allocation is a process of allocating memory at runtime. That means at the time of execution. For this, we are having some procedures, or I should say some methods are there for memory management function for allocating and freeing the memory at runtime. To do this dynamically and to allocate the memory dynamically, we have to include the standard library header file. So for that we have to include stdlib.h. Few functions which we are going to use for dynamic memory allocation are malloc, calloc, realloc, and free. As you can see, there are two brackets. Whenever these two brackets are coming in front of any variable name, they are function. So for example, main function, after main also you put this. Similarly, malloc is a function, or I should say it's a method. It's a memory management method, and definition for this function is written inside stdlib.h. So whenever I'm going to use this malloc, calloc, realloc, or free, I'm going to use stdlib.h in my program. Now, next, let's understand what is the difference between static memory allocation and dynamic memory allocation. So, as I told, static memory allocation, it allocates the memory at compile time. Dynamic memory allocation, it allocates the memory at runtime. For static memory allocation, memory cannot be increased while executing the program, because already we are doing it at the when we are writing the program, at that time only we are allocating the memory. But in dynamic memory allocation, we can increase or decrease the size at the time of execution. In static memory allocation, variables get allocated permanently. There is no way you can free the space. Whereas in dynamic memory allocation, variables get allocated only when program unit get activated, when you are running that particular unit. So static memory allocation is less efficient, and dynamic memory allocation, obviously, it's more efficient. There is no concept of memory usability for static memory allocation, because they are permanently getting allocated. Whereas in dynamic memory allocation, it supports memory usability. So after once we are done with the program, after we are done with the block, we can free the memory, right? So this way you can compare between static and dynamic memory allocation. In the coming videos, we are going to see programs and the concept for malloc, killoc, free, and realloc. Thank you for watching.